Hey to my geometry students out there. In this video, we're going to be looking at problem 68 of our week 2's assignment. Now, 68 really just sets up the problem for us. And then if you look at your book, we have problems 69 through 71. Those three problems are meant to guide you on how to solve problem 68. So it's okay if you have a 68, your answer is blank for 68 at first, because we're going to jump to 69, work through that 70 and 71, and that's going to help us solve 68. Okay, so 68 really just sets up the problem. We have this girl named Karina. She's playing tennis. She wants to serve the ball. When she serves the ball, she has to be outside of the court. And when she serves the ball, she wants it to land down here in this lower left corner. Okay, and they tell you some facts about the tennis court. They tell you that the distance from the net to where the ball is going to land, that is 21 feet, and that the distance from the net to the edge of the court is 39 feet, and then the playing area in the center is 27 feet, its width. Okay, and then we also know that the net is 3 feet tall, and they also tell us that Karina is 5 foot 7 inches. Okay, so lots and lots of different numbers to work with. We're going to jump right into problem 69 to help us solve this problem. So if you look at 69, they ask you to copy down this diagram of what we call a bird's eye view. Imagine that we're looking at this tennis court where Karina is, and we had like a drone, and we could see it right from the top. We would be looking at the layout this way. Okay, now we want the ball, going off of the illustration up here, we want this ball to land here in this lower left corner. I really want the ball to land right here, right? Just out of play so that Karina can win that match, okay? Now 69A says to label all the distances that we already know, okay? Well, we already know that the distance from this dot to the net is going to be 21 feet. And we also know that the distance from this net to the edge of the playing field is 39 feet. So I'm going to go ahead and write this as 39 feet. Okay. We also know that the distance from here to there is 27 feet. So now we just have to pick a spot of where we want Karina to serve the ball. And it's really okay if we all pick different spots here. I'm going to go ahead and put her in this upper right spot, kind of like the furthest distance away from where the ball should land. And I'm going to go back up to this diagram to show you Karina would be standing up here, and we want the ball to land right here. Okay, that kind of shows you how those two illustrations relate to each other. Now it asks us, do you see any triangles? Okay, it asks us, do you see any triangles? And it may not be super clear at first, but I think I do see some triangles. So what I'm going to go ahead and do is I'm going to go ahead and make a line. So I'll make it a red line. And I'm going to connect where I want the ball to land to where Karina is serving the ball. And you see here, I'm going to get this diagonal. It's really going to be a hypotenuse of a right triangle. And see if I can make it as straight as possible. There we go. That looks better. All right. So we have that distance. That is the distance that the ball is traveling, right? The ball is getting served from the green spot. It's landing, hitting the court down here at this lower left blue spot. Now, when I do this, I end up creating two different right triangles. I'll give you a second to see if you can see them. So we end up creating two different right triangles, right? So what I'm going to do is I'm going to, there's a lot of lines in this diagram. I'm going to kind of redraw it down here just so we can clearly see what we're looking at. So I have this bottom spot going like that. We go up, and then I have that connecting diagonal, right? And to help you reiterate where I'm coming from this example to down here, that green dot where Karina is still right there. Where the ball is landing is down here in the bottom. And I have this big triangle that I see here, but I also want to make sure I draw in, right, the net that was coming down. I want to make sure that I'm drawing in that net as well. Okay, so those are the two right triangles that we have. Okay, these are right triangles, and this little guy is kind of nested inside the bigger triangle. Okay, and I want to, again, make sure that we can draw in all of the labels for each side. I know that this bottom side here is 21 feet. I know that this part of the bottom right triangle is 39 feet. I know that this side here is 27 feet. Okay, and then I'm kind of out of sides. I don't know any other measurements for the sides, but 68 asks you to find all of the other sides. What other distances can you find? So I'm gonna go ahead and label, let's see, I'll pick the color red. I'm gonna label this guy as A, I'll label this guy as B, I'll label this guy as C. So in order to find out what these values are, a very quick way, kind of what we did in the last problem in week 1's assignment, is we want to look at these two triangles and set up ratios of sides. We have two similar triangles here. Okay, hopefully we can see that these two triangles that we formed are similar. They're similar by AA similarity, angle, angle. They both share a right angle, and they both share this angle down here. So they are similar. So let's say I wanted to solve side A. All I need to do is set up some side ratios. So I could put A over 21. So I'm gonna go ahead and write A over 21 equals, well, now I have to go to the bigger triangle. Since I used A on top as the numerator, I would use 27. And be careful now, okay? To get what this bottom one is, it wouldn't just be 39, it would be 21 plus 39. Okay, 21 plus 39. And that would give us a value of 60. And I am not going to do that work for you. I believe that you guys can do cross multiplying and solving, and you'll be able to figure out what A equals from that problem. Okay. Now, once you have A, you can quickly solve for B, because once you have A, you can just do Pythagorean's theorem for this smaller triangle to find out what B is. So you'll just do A squared plus, we'll use this guy as our B, and it's 21 squared. And then this is our hypotenuse, so it equals B squared. Now, whatever your A was in this problem, that's what you're going to put in for this A. And that's just a simple Pythagorean's theorem problem for you to solve for B equals. Okay, so you got A and you got B. The last thing to do is that you just have to solve for C. And to solve for C, that is just going to be another Pythagorean's theorem problem, right? On the bottom here, we have 21 plus 39. That gave us 60, so that will be our 60 squared. We'll have 27 as our side here, and it's going to equal now C squared, but all of this side here is our C squared, so it's really going to equal B plus C squared. Okay, so you're going to be solving, right? You're going to be solving for that whole length. Once you find that length, you just have to subtract out your B, and you'll find out what C equals. Okay, I'm going to stop the video here. I think this is a great intro. We have worked through problem 69. We are able to find these different values. And in the next video, we'll look at problem 70, which has a switch from the bird's eye view to a side view. All right, I'll see you next time.